Good evening. We have lecture number 8. In this, we are going to determine compressive strength of single angle section. So determine compressive strength of ISA 108 millimeter, length of angle 3 millimeter. 2 bolts are provided for hinged connection. So step 1, given data. Now when you are going to solve this, you have to keep your watch on. You have to see how much time you require to solve the problems. L is given 3000 mm. So we have 2 bolts hinged connection. 2 bolts hinged connection. Then we have step 2. Step 2, properties of section. So we have A equal to 1540 millimeter square. Then we have RVB we require. We need not require RXX or YY. We have RVB 19.5 millimeters. Then if required, we will write other data. Then we have step 3, classification. So we have B by T equal to D by T equal to 100 by 8, 12.5, less than 15.7, and B plus D by T, 100 plus 100 by 8 will be 25, that is equal to 25. Therefore, section is semi-compact. And therefore, AE equal to A. Then we have step 4, design compressive stress. Now we cannot use table over here as per IS. Clause number 7.5, we cannot go for the table. And therefore, we have to use the formula given for single angle section, which are on page number 48. So you can go to page number 48 and we have to find value of lambda E. Then we have lambda VB we have to first calculate, which will be L upon RVB divided by root of pi square E upon 250. Then we have to find lambda phi, which will be B1 plus B2 upon 2T, and then bottom will be as it is, root pi square E upon 250. Actually, as epsilon is here, so we are considering this as 1. So we will first calculate these values. So we have this as 3000 divided by 19.5 divided by root of pi square E, we have 2 into 10 raised to 5 divided by 250. So now if we will calculate this value, so denominator we will calculate, and which is the same for both. That is pi square E upon 250, pi square E upon 250, and root of this, it comes 88.86 is required for both. So I will calculate it. So into 3000 divided by 19.5, 1.73. Then lambda phi we have 100 plus 100 divided by 2 into 8 upon 88.86. So we have 200 divided by 16 divided by 88.86. It comes 0.14. Now we have to find value of lambda E, equivalent slenderness ratio, root of K1 plus K2 lambda VB square plus K3 lambda phi square. Now you can go to table 12, and on table 12 for 2 bolts and hinged connection. So we have 2 bolts and hinged connection. Value of K1 is given. So K1 is equal to 0.7. K2 we have 0.6 and K3 5. K2 0.6 and K3 5. So we will put this value in this equation. So we have K1 0.7 plus K2 we have 0.6 into 1.73 square plus 5 into lambda phi 0.14 square. And we will get this value, that is 5 into 0.14 square plus 0.6 into 1.73 square plus 0.7. Root of this is 1.61. Then knowing lambda E, we have for single angle section, buckling class is C, and therefore alpha 0.49. We have table 7, which is perfection factor. And therefore now by 7.1.2, page number 34, we have to first find value of phi. So phi we have 0.5 in bracket 1 plus alpha in bracket lambda E. Now equivalent slenderness ratio minus 0.2 plus lambda E square. And we will put this value 0.5 in bracket 1 plus alpha 0.49 lambda E we have calculated 1.61 minus 0.2 plus 1.61 square. And from this we will get this value, that is equal to 1.61 minus 0.2 into 0.49 plus 1 plus 1.61 square. And this comes into 0.5, this comes 2.14. So 1 plus 0.49 into 1.41 plus 1.61 square multiplied by 0.5. Now we will find value of FCD, and that is equal to Fy upon gamma mo divided by phi plus in bracket phi square minus lambda E square to the power 0.5. And then we will substitute the value 250 upon 1.1 divided by 5, we have 2.14 plus in bracket 2.14 square minus 1.61 square to the power 0.5. And then we will calculate this value. So we have 2.14 square minus 1.61 square to the power 0.5 plus 2.14 and then into 250 divided by 1.1, 64.02 Newton per mm square. So this value, once we know, then we can have easily PD. That PD we can calculate by using. So last step we have step 5, design compressive strength. Design compressive strength. And that is PD is equal to AE into FCD. AE we have 1540 into 64.02. Just see, we will use single angle section. Stress, compressive stress reduces a lot. So we have 98.59 into 10 raised to 3 Newton. So 98.59 kilonewton. So this is value of PD. So design compressive strength. Design compressive strength of angle 108 is 98.59 kilonewtons. So likewise, you have single angle, double angle, not much change. So we should be in position to solve this, and time you can see required hardly 15 minutes. So we will stop here only. Thank you.